Welcome to E-Trace Enhancements. Today's video we're actually going to dive into gas rings. So recent few projects that I've been doing have involved me getting into the gas rings, different kinds of gas rings between the McFarland, the JP one-piece gas rings, or the McFarland style, not necessarily by McFarland, and the three-piece. So I've done a bit of testing and I've tried it on different platforms and different things, and I'm going to show you what I've found, and I'm also going to tell you where these particular examples shine and where they could be a potential problem with them. So long story short, they both work. They're both good at their job. They just have a specific niche application in both scenarios, and one lends itself better to one thing and the other lends itself better to another thing. So they both do the job as they should. That's the final answer, but there is little things to factor in when choosing what gas rings to go with. And that is what we're going to look into today. So if you want to just keep it simple, stupid, use the tried and true three-piece. But if you want to venture out and accomplish a few extra things that the three-piece system cannot do, then you can continue watching this video so that you can get a full grasp of what exactly goes on and why the one-piece gas ring may or may not be a good application for you. So let's go ahead and get to it. Right off the bat, what I have here is, this is a McFarland style one-piece gas ring. This is for a 308 platform, AR10 if you will. I've got another Rubber City Armory one-piece gas ring, also McFarland style, just as a understanding of the type that it is. And then the second one is almost identical. It's the same thing, same company, same everything. Nothing too crazy here. Over here, I have a standard set of three-piece gas rings. The typical, nothing crazy there either. And then over here, these are for AR15s, both. This is all AR15 platform, and then over here is AR10 platform, 308, 6.5 Creedmoor, if you will. So these are also, once again, three-piece gas rings. So originally what prompted me to look at all this was seeking a reduction in drag. Specifically by drag I mean friction on the forward stroke, because if the gas rings are too tight, it prevents the bolt from sliding in and out. Typical concept of this would be whenever you do a gas ring run inspection or a gas ring check, where you would run the bolt or set the bolt carrier group in this position and see if the gas ring pressure is enough on the actual carrier to see if the gas rings themselves are worn or if they're good. Now, when you check for that kind of resistance, you are primarily checking the life of the gas rings. And I know that's what we were checking for initially, but what I really mean is the amount of material that has worn down from the gas rings exclusively. They are essentially spring-loaded elements that are opening into the journal or the gas ring run. So their primary design means that they have to spread out against it. That's the entire purpose of it. But the purpose of them spreading, I don't believe, has anything to do with the actual gas sealing properties of it. That is primarily what I believe. Now, I could be entirely wrong, and feel free to comment and tell me about all this if you are against my thoughts. I'm fully open to further discussion into this, but primarily my belief over them expanding is to account for tolerance stacking and potential wear over time. So as it starts wearing, because it's spring-loaded, it keeps expanding and it keeps taking its shape. Not to mention that if you have a bore that is substantially larger than the typical one, like the tolerances aren't just right, you end up having to take over that amount of slack. So in that sense, the three-piece gas rings, that's really where they shine. They shine in the primary aspect of their ability to conform to any bore, whether it be oblong as in ovaled out, or it be out of round, out of spec, something maybe not concentric, you name it. Any potential issues with the manufacturing of the gas ring run, they will allow to account for those differences, and they will wear accordingly. Now, depending on what's wrong with your gas ring run, your gas rings might not last very long. So realistically, where the three-piece gas rings really shine is in their ability to conform relatively well to the actual bore that they're trying to seal against. And whether that be shape or dimension, They can adapt to a really small inner diameter or a really large inner diameter. So the tolerance stacking purposes, the three-piece gas rings are amazing. And that's why they've proven to be so good. Now, they also have another benefit to them, which is something that a lot of people tend to forget in the manufacturing world. Me, in my experience at my job, I do a lot of product testing. And a lot of the product testing is purely based on one thing: cost of manufacture. And that's also another reason where these gas rings themselves shine. These are nothing but a piece of stamped sheet metal. That's all they are. And that's what makes them beautiful for the manufacturing industry, and what it makes them cheap, easily to manufacture, quick to manufacture, cost effective. And as a replacement / consumable item, these are fantastic. And that's why nobody has really gone through the trouble, or not that many people have gone through the trouble of redesigning this, because it just flat out works. It's a proven concept. This is a similar concept to that of an internal combustion engine, gasoline, diesel, you name it. They actually use a very similar design. Not entirely. I believe that from the design of these being themselves, I'm going to use a little Allen key to point at it. But when you look at this design, you have a thicker portion here and a thinner portion here. And then this part right here it's obviously beefed up. Now, there could be a myriad of reasons, and it's all going to be speculation as to why this could work or why it could be designed this way, but I'm going to go ahead and assume that the reason it's thicker over here and thinner over here is primarily for spring tension purposes and the ability for it to adapt to the bore. As obviously when you press over here, this will see higher forces than over here. So if you thin out this area, it allows it to conform more into the shape of a circle rather than just folding like a taco, if that makes sense. So there also, that clearance allows for a few things. One is for debris to actually flow through. Now you don't want a perfect seal on this. You want some flow through it. And that's another benefit of this particular system, is that it will allow flow. When it does compress, the gap itself closes and it reduces it to a minimum. You still want the flow. You want the flow because that will allow debris, carbon buildup, and whatnot to clear through and actually break through. If it were just a solid piece, the chances of it building carbon are substantially higher. And once again, that's where these guys shine. As far as the alignment with the gas rings, it doesn't matter. Even gasoline, diesel engines, it doesn't matter. The pressure is so high that these see that it really has no difference or effect. And if it is, it's so minute that it really doesn't matter. You don't have to worry about lining these up or keeping them staggered. They'll eventually rotate in whatever way they want to travel. So nothing to concern yourself with. And these are not inefficient. Another benefit to these, at least from what I learned in my automotive degree, is that the gas rings on a gasoline engine or diesel engine will actually have a clearance to where they'll sit in a groove that is essentially larger than the gas ring itself. And that is because the gas, when it comes around, will actually push down on the gas ring, and then gas will flow in behind the gas ring and actually press the gas ring out into the wall. That pressure will allow it to press harder against the wall. So in essence, these are very good at creating a good seal, and it's very well proven in the automotive industry. So that's where these guys shine, and they're amazing at that. Now, if you look at these and you tell me, okay, well, if these are so great, then why are we looking at these? And there is a main reason, or actually a few reasons, why these particular gas rings are in some ways better than these. But it is all dependent on your application and your needs. For 99% of the people, the three-piece gas rings are perfect. There's no need to change. They produce very little drag. They conform very well. They're inexpensive. They're plentiful. They just flat out work. But the majority of the data has been acquired through the AR15 three-piece gas rings. And the concept is very similar on the 308 platform. But my particular experience was that these gas rings created a lot of drag in the bolt. And primarily what I'm talking about is on the function of closing. So like when you have gas rings, the gas rings don't actually cause any friction on the bolt when it comes to rotation. But in order for the bolt to rotate, it actually has to travel through the cam path, which means that the gas rings themselves have to move within the gas ring run. And that is the primary issue with this style gas ring. It's not an issue really if you have a system with a very high spring pressure and a system with a higher operating pressure. But when you start dealing with something like 300 blackout, or how about 86 black, where you have primarily the use of a very low pressure cartridge, you now run into not having enough gas to send the bolt carrier rearwards. How do you fix that? Well, you can either reduce mass or reduce spring rate, or both. But when you reduce spring rate, you essentially remove the amount of energy of the bolt going forward, stripping the round, loading into the chamber. And the majority of the energy will be spent loading it. Then you have to fight the extractor. The extractor and the ejector will both fight you in the chambering of the cartridge. And that's the final stage. Well, not entirely. It's one of the final stages. Once its main goal is to jump over the rim and then lock into place. And then now, once it's done that, the lugs have the ability to rotate. Well, we've lost a lot of energy, so now we have a spring that it's at full extension with the least amount of pressure compared to when it's in full compression. And then you have this drag right there. It's not simple. It's not easy to push, especially when the spring has almost lost all of its energy and it's at the end of its travel. So what will happen is you'll end up in a scenario where, like, it didn't really fully go into battery. It'll go click. You'll be like, what happened? I don't know. Rack, eject around, load the next one. You might run into the same problem, or it'll be cured. So there's things to consider there. Now, like I said, on a standard AR15, this is nothing, because a standard power recoil spring, it'll do the job just fine. There's no need. And I was going to get later into the purpose of the POF roller cam pin, but for the intent and use of it, the standard setup, the 3-piece gas ring is perfectly fine. And the drag that it creates is almost non-existent and not bothersome. Now, we move on to, we are in the scenario where we have low spring pressure with, like, let's say a sprinkle yellow, and we have a low mass system, doesn't have eject energy going forward. You want to be able to, more than likely you have a very short barrel, which means you have to have very high extractor pressure and a decent ejector. So you need that stuff. So, and in order to be able to jump over that, you have all the energy going forward, you used it up, and then you want zero drag so that the bolt can do its job and lock. So we now move on to the benefits of the 1-piece gas ring. Now, these are supposed to be spring loaded, and they are. And the 1-piece gas rings are also technically springs. If you look at them, they're essentially just coiled springs. Coiled flat springs is what they are. Now, these have a lot of coils. Like, essentially they have 1, 2, 3, 4 coils, as opposed to the 3. They're thinner, but they are still 4 coils. And if you notice, there is actually, they don't fully go all the way around. I don't know if you can see that, but this is where it ends, and then the other one is all the way over there. Purposes of that, well, you can't really get a full flat spring if you have one side raised over the other. So in order for you to account for that difference, instead of it being cockeyed, you have to create a gap so that it can sit properly. Which means this gas ring will essentially do this when it's taking shape, which is good. It's actually a good thing for it to take the shape of what it needs to be in. So that's excellent. That's not a problem. And it having this opening right here allows for gas to come through it, whether that be to expand the ring, which is going to be completely more difficult than the standard gas ring, because unlike this gas ring, which has a thinner portion over here that allows it to flex more easily, this does not have it. It is uniform all the way around. So that is what we deal with. Now, let's get into the potential downside to this, and why this system, even though it's good, it's a little bit problematic. And one of the key things where it's problematic, and that is the 2 parts where the 3-piece gas ring actually shines, is that, number one, these have the ability to conform to any shape, and they have the ability to fill a hole that is really tight or really loose. Whereas this guy is kind of fixed in place. It really struggles taking a smaller shape than it is, and it will never expand to a larger shape, which means that its ability to adapt to smaller versus larger holes is very small. So it doesn't allow that much for the account or the tolerance stacking issues. And that's primarily why so many people have issues with it. Some people will swear by it, and other people will hate it because it causes too much drag. So when you put this on a bolt, if this outer diameter is too tight for the inner diameter of your gas ring or your bulk carrier, they will create a ton of drag. They will adapt. They will compress into it. But now you have a bunch, like 4 little rings, trying to stay in shape, just compressing and fighting against the wall. And that creates a ton of drag. And that is primarily the problem, is the tolerance stacking portion. These are not as good at adapting to the outer diameter as the one-piece gas rings are. So in essence, what this means is that the tolerance control, in order for you to be able to use these, has to be much higher, which therefore that ups the cost. Not to mention that manufacturing this is a lot more expensive than manufacturing a piece of stamped sheet metal. So these, you actually have to have, I mean, I don't know the entire process of manufacturing, but you can tell just by the sheer cuts, the shape of it, the way that they have to make sure that they actually get and stay round. There's expensive machinery making these, and you also have to start with a base material. So you have to be able to first make it into shape, then coil it, then make sure the coils are in the right position, make sure that the cuts are in the right place. There's just a lot, versus like this, where a machine just comes down and stamps it. Done. It's super easy. It's a cookie cutter mold, essentially is what it is. Well, this one is not. This requires the full manufacturing process of a standard spring. So there's the downfall. Now, these can work fantastic at reducing drag if they are the proper size, because they don't necessarily have to expand to be able to seal. They are very good at taking shape, moving around, taking the position of the bolt. If the bolt is moving, they can swirl around with it, which is excellent. They allow the seal. But once again, if the hole is too tight, they will create a ton of drag. And even though they will seal with all that drag, you are now causing yourself a problem that you are trying to eliminate, aka friction. So from there, we move on to my experiences. So I went with the one-piece gas ring because I was trying to eliminate the drag that these cause. These create more drag, mainly because they are thicker. Therefore, they put more load. They're more thicker as far as this way, in the springy portion of it, which therefore they put more pressure on the walls. So I'm trying to eliminate that. So here I come, and I ordered this one-piece gas ring. This was for Rubber City Armory, and I ordered a few. I ordered one AR10 because that's what I was looking to do, and then 2 AR15s because I figured if this works out really good, then I'm going to want these. So luckily, these standard type McFarlands are fairly cheap. I think they're like $2-3 a piece. So it's really not that bad. And as far as like purchasing wise, I think they're just like $1 more than the standard gas rings. It's not that big of a deal. But what did I find? What I found is that in the inner diameter of the 308 bulk carrier, this fit perfectly. It actually reduced all the drag. Like, you could feel it there moving, but the amount of drag put against those walls was changed astronomically, which is not the same effect that I had with the AR15 gas rings. These, you can see, they've got carbon buildup. I used them on a 300 blackout and an AR15 platform, and for all intents and purposes, they did do their job. The gun cycled, the gun was reliable, the gun worked. But what happened was that at the end of the day, once the carbon had set in, the amount of friction that these things were creating was insane. Like, if you tried to, at any point, load the bulk carrier forward slowly, you legit had to use the forward assist. Like, it's either it slams forward and it locks in, or if it slows down for any reason, you legit had to use the forward assist to send it forward. Not to mention that they also weren't very good at moving around. Like, once they're in there, they kind of just stay in place, as opposed to these other ones that kind of tend to wander around or send gases in different directions to really break up the carbon buildup. So on my AR15 platform, everything was fine except for a ton of drag. And then on the 300 blackout, it actually locked in place. And that could be just based on the groove cutout of the bolt itself, the tolerances. And it locked in hard, which is why this one's a little bit bent. You can see this little leg kicking out like that. That is because I legit had to like pry it out. It was bad. It was stuck in there. And then when I did pry it out, there's a ton of carbon buildup underneath it. And it's definitely exacerbated by the use of a suppressor. So that being said, that doesn't mean these are bad. It's just that for my particular use, in the particular bore that I was using, they were too tight. And they actually caused more problems than they resolved. So with that all being said, you're like, well, if it's so specific to tolerances, then why are we even looking at these? Well, They have the benefit of the reduced drag, assuming that you have the right tolerances, and they also physically are stronger. What that means is that they, number one, they're not being forced out into the chamber to create that drag and seal the typical way that a gas ring would. So they're not being forced to wear down, but they are also physically more supported and have, I don't want to say more material, but because the material is more uniform, it essentially leads to a stronger gas ring. And that is particularly why what I believe the Crane Spec Mark 18 uses a one-piece gas ring. The gas system in the Mark 18 is so violent that I'm sure they were just going through gas rings. And it's primarily because of the function, not necessarily of it sealing the gases from escaping, but the fact that the gases are actually getting underneath it and forcing it to expand. So the wear element right there is substantial. So these don't lend themselves too much to that, as I've explained. I may be wrong. They might actually do that just as well. But that being said, the nature of this guy is stronger against its ability to expand, not to mention that they are already at a smaller size. Therefore, you have to fight the material more as opposed to this material actually assisting in the spreading. So it makes a difference. So, what do you do now? Like, which one do you pick? Well, the way that you solve this problem with the McFarlands is that, and the only time that I would go with a standard McFarland is if you have a particular bore that is wearing out your gas rings, your three-piece gas rings relatively quickly. If you have that, I would go with the one-piece gas ring because this gas ring will survive for much longer than these guys will. Not to mention that you already have a tolerance stacking issue where your bore is potentially too big. So therefore, these being slightly oversized or the wrong size if they are slightly larger, you will essentially be filling that gap and causing yourself less problems over the course of time. So now we move on to take a few steps back to the actual one-piece gas ring reducing drag. So the primary issue with these is the fact of tolerance stacking. So how do we fix that? Well, there is a fix, and it's already on the market. It's called the JP Enhanced Gas Ring. So here's my 308 bulk carrier. You can see very little energy required. Fails the gas ring run test. And that's okay because of the design of the gas ring. So this is primarily the only gun right now that I'm using a one-piece gas ring. And one of the things that you can tell right there, right off the bat, is how shiny this one-piece gas ring is. And JP actually advertises this, and that is that they create a surface grind on the outside for this particular gas ring. And their goal for that is absolute control of tolerance stacking, at least for the gas ring, as best as they can. They found the diameter that will work best in tighter bores and the diameter that will work best in wider bores, or tighter and wider bores, essentially. So the action of this super stiff spring expanding and being smaller doesn't affect as much. If it's too tight, then it will actually give, versus if it's too loose, where it'll at least act as a seal and it has its minimum spec. So there's only so much you can do, but for a company like JP, where they have extreme control over their tolerance stacking, which can be proven in several SOTAR videos, the use of this gas ring is actually a great idea. Now it's more costly, but because they're able to control those tolerance stacking, they have essentially created a gas ring that is more durable, better gas seal, and with the biggest benefit is reduction in drag and friction. So they have essentially eliminated one of the biggest problems, and that is primarily because of their competition nature, which is requiring a very low mass bulk carrier with very weak springs, and essentially the least amount of energy used to cycle the gun, because more energy movement means more motion off target. So in essence, that is primarily what they do. Everything they've done is to reduce friction. So in that aspect, the JP is actually the best out of all of them. Now, the JP could be a problem if you have a particular oversized bore. Maybe in that case, the McFarland one might work, but the fact of the matter is that tolerance stacking is all over the place, so it's kind of a hard one. And at that point, I would really not blame your gas rings, I would blame your bulk carrier. So in that sense, once again, this is where this guy shines. Not to mention that there is a slight difference on this JP gas ring versus the McFarland, and that is that not only do they do the surface grind and completely flatten out the edges, as opposed to them having almost like a rounded edge that will improve contact point, which will essentially reduce drag as well, because the contact points isn't so concentrated with a lot of load behind it. It's more evenly spread out. So not only that, but they actually use one coil less, but still retain the same diameter. This is a 3-coil system with 2 coils in the center, right there at the cutout, whereas this one is essentially a 4 or 5 coil with 3 in the center. So this in itself, once again, this would have more of an ability to take the shape of the bore if there is more of an oblong shape, but this will create less drag in general because there's more surface contact per the amount of force that is being enacted on the wall. So there's a lot of things to nitpick here, but that is essentially the gist of it. And in both scenarios, this gas ring had almost no drag on my bolt carrier, and this gas ring has almost no drag on my bolt carrier. The difference here is that this one is essentially polished and ground to the specific surface, whereas this one is just finished off like this, and you can't really, I don't think they really check for the outer dimensions. So in this case, I got lucky with the 3 bolt carrier, but on the AR15 ones, it was too much drag. So if you go with JP, one-piece gas ring, more than likely, they did the same thing, which, well, not more than likely, they actually did the same thing with the AR15s. And they are going to have a higher control of outer diameter measurements to essentially alleviate the problem, and therefore not come out with too much drag, but instead with a reduction in drag, which is the goal. Now, them allowing them to do that means they can run this gas ring, which has the benefit of preventing wear on the bolt carrier. I believe they use titanium and aluminum on some of their bolt carriers, so that will extend the life of the bolt carrier by putting less pressure against the walls, and it will actually create a stouter gas ring altogether. So longevity of the parts are greatly increased, but at an increase in cost. And that's where we roll back down the hill to one-piece gas rings, where they have a life expectancy. They're considered wear items, and that's fine. So really it depends on your application. I would say one-piece gas ring if you're looking to reduce drag. However, I would completely skip these in particular, the McFarland style, because there is no tolerance control once they are manufactured. It is what it is. You're either falling in the right territory or it's going to be a shit show for you. So if you want to play it safe, pay the extra money and purchase the JP one, but only do so if your goal is to reduce friction. If your goal is not to reduce friction, stick to the 3-piece gas rings. They will serve you well. You won't have to test them out. They're well proven and vetted. And then the other element to consider in moving over from 3-piece to a 1-piece is how fast does your bolt carrier consume gas rings. If your bolt carrier has issues consuming gas rings, then definitely take a look at the McFarlands or the JPs. I would go ahead and order both. Or you could go the cheap route and order McFarland first, or McFarland style, Rubber City Armor, you name it. There's a lot of companies making them now. And then place this in your rifle, let it break in. It potentially will have more drag, but the lifespan of your gas ring will be substantially higher. The one thing is you have to make sure that they're not locking in place. And that is more of a problem with suppressed firearms anyway, because they introduce more gas into the system. So if trying to reduce drag, one-piece gas ring, JP is your best bet. If trying to increase lifespan of the gas rings, the McFarland style would be a good idea, especially if the reason that your gas rings are being consumed is because of oversized gas ring run. And if none of this applies to you, if either friction or gas ring wear applies to you, then don't even look at these. Just go straight for the standard ones. And that's it. That's all it is. Now, I know this is a very long video, so I apologize, but there is a lot to mention, and there's a lot of things to consider when choosing gas rings. It's not just as simple as, yes, it works, or no, it doesn't work. There's a lot of information backing it, and there's a lot of reasons to use one versus the other, as well as one of the primary driving factors is cost of manufacture. So that pretty much resolves the entire video. If you made it this far, holy crap, I'm impressed. And you're the type of guy like me that actually likes to listen to all this kind of crap. But otherwise, I already said the information at the beginning of the video, so there you go. This just further proves it. Now you have a better explanation, understanding of the entire concept behind it, and why one's better than the other in specific scenarios. Anyway, I'm sorry for boring you to death. If you like this content, please don't hesitate to subscribe. I'm going to be doing a lot more analysis videos. I don't know if my particular crowd likes this kind of analysis videos, but it is something that I'm passionate about. So I'm going to keep making these posts because I like showing my data gatherings rather than just keeping it to myself. So Anyway, I hope you like this video, and please comment, rate, and subscribe. Thank you.